This question was asked in GATE 2017 Electronics and Communication Engineering paper set 1, in which you have given two discrete time signals, one is x of n and h of n. Both signals are non-zero only for the value n equal to 0, 1 and 2, and 0 for other than this n equal to 0, 1 and 2. You have also given x of 0 as 1 and x of 1 as 2 and x of 2 as 1, and you have given h of 0 as 1. Now you have one more signal y of n, which is a linear convolution of x of n and h of n. Given that y of 1 is 3 and y of 2 as 4, then you need to find out the value of expression, that is 10 times y of 3 plus y of 4. The NPTEL reference for this question is Principle of Signal and System by Professor Aditya Jagannatham. You can find reference in the lecture, which is Properties of Discrete Time LTI System. Now, coming to the useful data slide, if you have given a signal which is x of n equal to a, b and c, and this is your n equal to 0th sample, so you can write this signal as a of, and if it is your n equal to -1 and it is your n equal to +1, then you can write this signal in the impulse signal representation as a times delta of n plus 1 plus b times delta of n plus c times delta of n minus 1. So this is the impulse signal representation of a discrete time signal whose values are a, b and c. Now the second useful data for this question is, if you convolve this two impulse signal, which is one at n1 and second at n2, that is delta n minus n2, then you will get this convolution as delta of n minus n1 minus n2. Now this is the second useful data for this question. Now the third useful data for this question is the definition of convolution. So if you have given yn equal to convolution of xn with h of n, then the definition of this will be given as k equal to minus infinity to infinity x of k into h of n minus k. So these three are the useful data for this question. Now in this question you have given x of n as 1 to 1, that is n equal to 0 value is 1 and n equal to 2 value as 1 and n equal to 1 is 2. So it is given in the question. So you can represent in this impulse signal representation as delta of n plus 2 times delta of n minus 1 plus delta of n minus 2. This way you can represent x of n. Now you have given that h of n has value at n equal to 0 and 1 and 2, but you have given only h of 0 value, which is equal to 1, but h of 1 and h of 2 is not given. So you can take h of n as 1 a b. You assume that a is the value of h of 1 and h of 2 value as b. So this is your n equal to 0 point. Now similarly you can represent it in impulse signal representation as delta of n plus a times delta of n minus 1 plus b times delta of n minus 2. Now you have given yn equal to xn convolution with h of n. So you have given x of n as delta of n plus 2 times delta of n minus 1 plus delta of n minus 2, and this convolve with this h of n, which is delta of n plus a times delta of n minus 1 plus b times delta of n minus 2. So by using this property that if you convolve this delta of n minus n1 with delta of n minus n2, then you will get delta of n minus n1 minus n2. So by using this property, you can convolve these three impulses with these three impulses, and you will get delta of n convolved with delta of n plus delta of n, a times delta of n convolved with delta of n minus 1 plus b times delta of n convolved with delta of n minus 2 plus 2 times delta of n minus 1 convolved with delta of n plus 2a times delta of n minus 1 delta of n minus 1 convolved with delta of n minus 1 plus 2b times delta of n minus 1 convolved with delta of n minus 2 plus this delta n minus 2 will be convolved with delta n plus a times delta of n minus 2 convolved with this delta of n minus 1 plus b times delta of n minus 2 convolved with delta of n minus 2. So now this will give you only delta of n. Similarly, this will give you delta of n minus 1, and you can find all the convolution using this delta signal convolution operation. Now, so finally you will get y of n as delta of n plus a plus 2 into delta of n minus 1 plus 2a plus b plus 1 into delta of n minus 2 plus 2b plus a delta n minus 3 plus b times delta of n minus 4. So your yn value can be given in the sample form as this is your 1, this is n equal to 0. Now the second sample is a plus 2. The second sample is a plus 2, which is at n equal to 1. Similarly, the third one is 2a plus b plus 1. The fourth one is 2b plus a, and the last one is b. Now you have given y of 1 as 3. This implies a plus 2 equal to 3, which means that a equal to 1. Now you have also given y of 2 equal to 4. So this implies that 2a plus b equal to 4. You have given a equal to 1. So when you put a equal to 1 in this equation, you will get b equal to 1. So you can find y of 3 as 2b plus a, which is equal to 3, and y of 4 equal to b, which is equal to 1. So you have asked in the question, you need to find out that 10 times y of 3 plus y of 4. So y of 3 is 3, and this becomes 10 into 3 plus 1, which is equal to 31. So one way is to solve by this delta signal representation of the samples of x of n. The second way is the tabulation format. So you have given x of n as 1 comma 2 comma 1 and h of n as 1 comma a comma b. You assume that n equal to 1 value of h of n as a, and at n equal to 2 the value of h of n as b. Now you can take this table. Here you write down the x of n and here h of n. Now Write down these values of x of n and h of n like n equal to 0, that is 1, n equal to 1, and n equal to 2. Similarly, for this, write down this 1, a and b. Now multiply this 1 by these 3 and write down the corresponding row table. So when you multiply this 1 by this 1ab, it will become 1. 1 into a becomes a. This is b. Similarly, when you multiply by 2, then it becomes 2 times 1, that is 2. 2 into a, it becomes 2a. Now the third one, 2 into b, it becomes 2b. Similarly, for third one, it becomes 1a and b. Now you have to take the row element. So this is your row element, and you need to add all the row element. So the first value becomes 1, the second becomes a plus 2, the third one 1 plus 2a plus b, which is becomes 2a plus b plus 1. Similarly, the fourth one becomes a plus 2b, and the fifth one as b. Now where is your 0 point? So let's say if you x of n is lying from n1 to n2 and your h of n is lying from n3 to n4, where n1 can take any value, that is 0 or -1 or anything. So if you convolve these two signals, then your y of n will be lying between n1 plus n3 to n2 plus n4. So now in this given x of n and h of n equal to 0, and this is n equal to 0, so 0 plus 0 becomes 0, and n equal to 2 and n equal to 2, so it becomes 0 to 4. So you can write y of n as 1 a plus 2, 2a plus b plus 1, a plus 2b, comma b. So this is your y of n expression, and this is your n equal to 0 point. So this is the same y of n as you get previously. So you can solve by putting the condition y of 1 as 3 and y of 2 as 4, and you will get a and b, a equal to 1 and b equal to 1, and you will get 10 times y of 3 plus y of 4 equal to 31. So this is the another way to solve this problem.